So this is a theorem. It's a tautology, either P or not P. This sequent, where we represent either P or not P as a conclusion, where the premises is the empty set, every tautology can be proved on the empty set of premises. So we should be able to prove this sentence. Well, obviously we don't have any premises, so whatever is going to appear on line 1 is not a premise. But obviously it must be an assumption, because if the rule here weren't assumption, it would have to refer to an earlier line. So we must be making an assumption here, either for arrow introduction or reductio. Now in this case, it can't be arrow introduction because we're not trying to prove a conditional. So it must be that we assume the denial of this and then try and show that leads to a contradiction. So we assume it is not the case that either P or not P. An assumption for reductio. And now we need to generate a contradiction, which means two sentences that deny each other, one of which then must be a negation, and this is obviously itself a negation. Well, suppose we assume P again for reductio. Wedge introduction is a one-line rule. It allows us to form a disjunction with a sentence we have already, and the other disjunct can be anything we like. So 2 wedge introduction, 2 is P, so we could form this disjunction, either P or not P. Obviously, if the sentence on 2 is true, the sentence on 3 is true. So that's truth preserving. But 1 and 3 can't both be true. 3 says either P or not P, and 1 says neither P nor not P. So by reductio, from 1 and 3, we can conclude the denial of 2, not P. We cite 2 sentences which can't both be true, neither P nor not P, and either P or not P, the rule reductio, and then we discharge the assumption on 2 by denying it, not P. Well, 4 is a sentence. We could make it the right disjunct of this disjunction. So this would be 4 wedge introduction. If the sentence on 4 is true, the sentence on 5 must be true, right? The sentence on 4 says it's not the case that P, and the sentence on 5 says either P or it's not the case that P. So there's no way the sentence on 4 could be true without this being true. But obviously 1 and 5 contradict each other. So now we say 1, 5 reductio, and we discharge the only assumption on which both 1 and 5 rest, which is 1, and we then get the denial of 1, which is either P or not P, by reductio, and the assumption set is empty. So here we discharge the assumption we made on 2, here we discharge the assumption we made on 1. Those are the only 2 assumptions we made. And so the assumption set here is empty. And what we have here is a proof of the theorem, either P or not P, on the empty set of premises, and this is what a theorem proof is.